In this work, we propose a method to simultaneously track the shape of multiple deformable linear objects. The convention is to represent the shape of a deformable linear object with a set of nodes and edges. The tracking process takes a continuous RGB-D stream as input and updates the nodes and edges by solving it as a non-rigid registration problem. Given a RGB-D stream of multiple deformable linear objects, we first perform instance segmentation on the first frame to initialize a set of nodes and edges for each object in the frame. This step is performed manually due to the limitations of existing instance segmentation algorithms. After initialization, all objects are combined into one big object and tracked together using the Global-Local Topology Preservation algorithm. Only semantic segmentation is required for all subsequent frames, which can be easily obtained. We utilize the geodesic distance metric to keep each individual object separate in the combined object. GLTP is based on the motion coherence theory, which states that features spatially close to each other tend to move in similar directions and speeds. Here we assume the movement of a node only correlates to the movements of its neighbors, not nodes on another object. When using GLTP, we use geodesic distance for nodes on the same object and set the distance between nodes on different objects to infinity. Here are videos of the two experiments included in our extended abstract. The proposed method currently has several limitations. In the tracking results produced, different objects sometimes penetrate through each other, which is not physically possible. Additionally, the proposed method is sensitive to poor depth, quality, and occlusion. This concludes my talk. Thanks for listening.